الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
السلام عليكم ورحمة الله تعالى وبركاته. أهلا بكم في عدد جديد من MENA ديجيتال داي الأيام الرقمية. معكم عليان عبد النور جي تي وزو الجزائر. اليوم بإذن الله سنكمل الدرس حول جوجل كلاود بلاتفورم عن الكلاود. السيشن ستكون بالإنجليزي. Hello everyone, الزول فلاون. Aliane Abdenour with you from Tizi Ouzou, GDG Tizi Ouzou, Algeria. Today, بإذن we are going to see the third session about Cloud Run, where we are going to practice, and then we are going, of course, to discover this concept called the 12-factor apps, where we are going to discover how applications are done in 2021 and the latest standards, and then we are going to apply them on GCP, Google Cloud Platform. So, of course, if you have any question, you can ask them, no problem. We will try to answer. So, let's go. So, this is the third session. In the previous two sessions, we saw what is a container, what is a virtual machine, and then we saw how things begin using App Engine Flex, and App Engine Standard. And then in the App Engine Standard, we saw that there is two generation, first generation and second generation, and everything is based on a container. The difference between Flex and App Engine Classic or the standard environment is that the first one in the Flex, it is up for the user to provide the container, the Docker container. But in the App Engine standard, you write your code and it will be converted to a container using, and it will be isolated using the gvisor. So today we are going to dive and directly discover what is Cloud Run. So before we begin, I want you to know this tool. This is called Google Keep. I think that if you have Android, you need this tool. So Google Keep, this is a tool where you are going to store like to do. For example, you have something to do for today or tomorrow, and then you want to make notes. It's easy. And it will be synchronized between all your sessions on your Google Chrome, on your Android, on your TV. So this is a nice tool. So today we are going to use this. And of course, I shared with you the links where you can download the extension. So on desktop, on Windows or Linux, there are two kinds of extensions. There is the extension that makes you directly click here, and then this session, this link will be automatically bookmarked. So if, for example, I found this link and it is interesting, I just click here, and then I will add him a tag, for example, DevOps and Docker, and that's fine. So next time, if I go to Google Keep, I will find it. Or, for example, you want to be reminded in a place, so you just write something, and then you give him the place, and then once you get to that place, it will remind you. So this is out of the topic of today about cloud, but it is a tool that you need to use. And of course, you can modify the note directly on Google Docs. In case of you have something longer than a simple note, you can directly go to Google Docs. So it's a tool, it's a must-have tool. And the second tool, this is a desktop extension that you can directly use without going to the browser. So, and then there is a third extension that I added to make you use in full screen. So if I disable the full screen, as you can see, this is by default. So here are my notes. So every time I have something to do, I will add it to the note. If I click here, I can pin the note. I can add another color. I can add a picture. I can add the collaborator people. And then I will use the full screen and I'm done. So every time I do something, I can click here and then I show people that I have done this this to do, this for example, this operation. So I used Google Keep to write the 12-factor apps in a way to make it like a program. So this is our program. We have 12 operation or factors, and then every time I will finish a factor, I will click on it, something like it's already done. I have done it. So the objective of our 12 app factor is that we realize, so let me zoom because this is like this is just a browser. This is a web app. So our objective is to decouple the component of our application. Why? To make it scalable. So we have three objectives. So in case you want to make an application on web or on on-premise, then you need three objectives. It must be portable, it must be scalable, and it must be automatable. What does it mean? Is that a portable, you will not depend on an operating system or in a host. For example, you host your application somewhere. You should not depend on that host because tomorrow they will close, they will change their politics. Then you need to change. So you need to have your application portable to be easily deployable somewhere else. For example, you were at AWS and then you want to go to GCP, that's fine. You just bring it to GCP and it will work. And then it will be scalable. Scalable, that means that you need to scale. You need a way that you are not limited with 100 people or 1,000 people. You need to think about humanity. You need to think that how you are going to deploy your application to the whole world, not only for few people. And then it must be automatable. What does it mean? That because in the computer world, in the IT world, you need to do something that must be automatable. This is the principle of computer. After all, we are trying to automate stuff on the computer. That's what is a program. Instead of doing the paper and the pen and writing stuff, we are trying to automate them. So those are the three objectives. So we decouple our application to make it portable, scalable, and automatable. So now we will start our 12 factors. So the 12 factor, this is their website. So if I type 12 factor, and of course the link are shared app, it will bring me to this website where it has a free book and everything is explained. So the 12 factor, it has been, I think it was invented in 2011, where people started this movement of microservices. So they are like how we are going to make our application perfectly scalable and automatable, what we just saw. So they are numbered from 1 to 12. So what I did, the difference here is that I will not explain them in the orders. So I inverted some orders, for example, 1, 2, 3, 4, and then 10 to make it just like to make the sequence much more understandable. So let's start. And of course, every time I talk about one factor, I will apply what I just explained directly on GCP. So the first one is Codebase. What does it mean, this factor is that we need one single code base, many deployments. And this is what we do in GitHub. So what we do in GitHub is that we host an application. So if I come to GitHub and we host an application, once we host it, we must do something where our code must reside in one code base. Our collaborator or people that I work with them, they come here and they connect to the same source, and then they modify the same source, and then all the team must see the same source. So we have here two options. We use GitHub, or for example, Bitbucket, or because we are in GCP, we directly use what we call the source repository. So the source repository, this is the GitHub hosted on GCP. This is what we do in GitHub. This is exactly what we are going to do on GCP. So the commands, this is the same command where we are going to write git. So every time we write git, we are using a repository, and the repository, it can be hosted on our machine. We can create our private repository, or we can create a public repository. So on GCP, that's the same thing. Here, it's a private repository. On GitHub, we can create a private repository, or we can create a public repository. But we need here to stay on GCP, because we will have a lot of advantages when we stay on GCP. So the first factor here, this is to make one code base, one single code base, mini deployment. So I will always stay on this repository, and then every time if I change my source code, I stay always in one single repository where my collaborators will come and see and check and modify, and then I can realize a lot of deployment. So the first one, it's done. This is where we are configured. And the way where we configure it, we already saw it on the video. So we just create a new one. But here the difference is, I think it's the same thing. It's like GitHub. We need to generate our SSHK. Once we generated our SSHK, we just do git push, because I think there are many videos about git. Even on MENA Digital Days, there are amazing videos in Arabic and in English. You can check them later. So I made my repository here, and I'm going to work on it. So the first one, done. The second one, dependencies. So dependencies is that if I come here, if I have my code, I wrote it on Python, I need to write dependencies. Dependencies are, for example, other libraries or other code that my application depend on. So I should never, for example, I give you an example. You already installed WAMP on Windows. The problem with WAMP on Windows is that many people say, hey, I need the DLL file. So here we didn't respect the second factor. Why we didn't respect our second factor? Because I didn't provided the DLL. Maybe it's about some restrictions, some property. For example, DLL, it belongs to some, for example, to Microsoft. I cannot give it for free. So that's why you need to be sure that when you give me the source code, you must provide the dependencies with it, or at least show me the place where I can download them. You should not give me, because it's a puzzle, you should not give me the one piece of the puzzle and one piece is missing. So the dependencies in Python, we do it in this file. So requirements, what we do, we include the requirements, which are the dependencies. Or for example, if you come from Node.js, you include them in the npm when you use the tool called npm, and then you install the dependencies. So in Python, we write them on a file called requirement.txt, and then we write the command that is called pip. This is the command we use in Python. pip to make us install the dependencies. And I will come back to this. So I will just do something like this and leave it because I will come back. And then the configuration. So the configuration, we should never do something like this. So let me run. Here, this is a virtual machine. This is using a VirtualBox. Why? Last session you saw me using the Hyper-V client, and then I got some issues because you need a lot of stuff to configure it with Ubuntu to make it full screen and so on. So I prefer to come back to VirtualBox and disable Hyper-V on Windows, because I told you when Hyper-V is enabled, you will get bad performance on VirtualBox. So what I do, I will go to my website and then I do code. I will use VS Code, Visual Studio Code. I think everyone is using them. So I will hide this and then I zoom. So here is what we will never do again. Never write the configuration or some information inside your source code. So if I come back here, you should store always the configuration outside your code. Never store them in your source code. So what this code becomes, I need to delete this and then write a variable, for example, and call it, for example, root db. And then this, I will write pwdb. They must be variables. And then this, for example, tdb for title database. And then what I do, I will save them as environment variable. So here is what is an environment variable. So if I do echo $path, the path is the first variable we have in operating system. But I can do export, for example, my name equals Abdullah. So if I want to retrieve this variable, I will not use this name directly on my source code. What I do, I will do my name. So every time I execute my code, I should never put this name on my source code for security reason and for scalability reasons. So for example, if I want to change my for example, my administrator, my database administrator, I don't have to go to my source code and modify it. And that's what we call hard coding it. I must put something outside my source code to be easily modified. So if I go to Python, I will show you how we can retrieve this variable. So I didn't install Python 2. I use Python 3. So I do import OS and then os.environ, and then in environ I will get my variable called how did I call it? Name, something like, I will just write path, and this is the variable. So if I do this and then write name, I don't have the name. So if I want all the variable, what I do, here is all what I get. So if I do items, or let me bring the case, and I have all the variable, the environment variable, and those are the ones that I will write in my source code. I will not hard code my, which means don't do that. Don't write your source code like this. Always think environment variable. Don't hard code your variable. So if I come back here, I did it. Configuration. Now backend services. Backend services, because we are using an application, we need a database. you need to make a way to never use the database where if you change the vendor, you will need to change all the source code. You need to use a way where your database must stay the same even if you change the vendor. So always think how to keep your database or a message broker to make it easily portable. For example, I work on MySQL, I go to GCP. If I come to GCP, I can find here MySQL directly on Cloud SQL, where I will show you this. If I go to SQL, I can have two choices. I can use MySQL or I will use Postgres. So if your application is already on MySQL or Postgres, that will be easily portable on GCP. So I can use, let me zoom here so you can see, I can use MySQL or Postgres. That's it. And it will be easily portable on GCP. So the configuration, I will show it, this, I will show it in few minutes, the config. So the backend service, it's done. Now, build, release, and run. And this is what we are going now to do with Cloud Run. So let's have my first application. I have my source code hosted on Cloud Repository. What I do, I will go to Cloud Run. I will run now my application in two ways, how we were working in the past and how it's done now. So let me create a new service because we are talking microservices. So every time I'm going to host an application, it's a list of services. So here it asks me, where is your container? Because we said that Cloud Run, it runs containers. So if I do select, it tells me where your container is hosted. Is it hosted on container registry or artifact registry? So here, if you already hosted, so what is a container registry? A container registry, this is like Docker Hub. So Docker Hub, people use Docker. They create their containers, but they must host them somewhere because remember, this first code base, one single code base, mini deployment, because even your container must stay somewhere. So Docker Hub, this is the place where we host our Docker. So if I do, for example, Ubuntu, it will bring me the image. So in GCP, we have our Docker Hub, but special for GCP. And this is what we call container registry. So container registry, it always starts with GCR. Where we find the word GCR, GCR for container registry. So Google container registry. So Google or container registry, GCR, this is the Docker Hub for GCP. And then recently we use artifact registry because in artifact registry, not only we can host our containers, but we can host even our NPM or our PIP, our dependencies. So all our dependencies, they are here. So remember, we are here. So our dependencies, we host them directly on artifact registry. So we are done. But since I don't have a container, I didn't compile anything, but I have my source code, I will say continuously deploy new revision. And then here it asks me to set up Cloud Build. Now Cloud Build, this is Cloud Build. So I have my source code. I have here, this is the source. So what happens, I will upload it to some storage that we will see now, the title. This storage, it will send it to some container. And then this container, I will bring it back to Cloud Run. So the storage on GCP, because I'm not going to use my storage, I need to store it somewhere where it is inside the GCP. This is called the Google. Let me show you directly here. Better to show you directly here. This is called the Google Cloud Storage. So Google Cloud Storage, we already used that last session. It is what we call the object storage or the bucket storage. And then you will find always called GCR. GCS, sorry. GCR for Google Container Registry. Now it's called GCS. So the GCS, it will bring it, our source code, it goes to GCS, and then in the GCS, we need to build it. And then once it's built, I will not run it directly. I need to send it to GCR, Google Container Registry, and from the Google Container Registry, I will run it. And this is the path. So here I have one source code. I will upload it to GCS, or since I don't use my machine, I can bring it, for example, from GitHub or from source repository. And that's what I'm using now. I'm bringing it from source repository. Source repository, it brings to GCS. From GCS, it creates a container. And then this container, it goes to GCR. And this GCR, it comes to Cloud Run. And this is what we call cloud build. So I need now to make a way every time I upload the source, I must fire this build every time. I don't have to do this manually. I must do it automatically. And that's what we will see now. So let me close the GCS. So I come here and then I tell him, set up the cloud build. In the cloud build now, it asks me where your code source is hosted. I say, no, this is not in GitHub. This is here. This is in Cloud Source Repository. And then it asks me which repository. And then when I click here, in reality, I am bringing this repository. In this repository now, I do next. And then it asks me, which branch are you going to build every time? Because you need to understand one thing. When we use source code, we always create a lot of branches. Why? Because there is a branch that is ready for the deployment, and then there is a branch where we are training on it. We are trying some modifications, but we don't validate them yet. So here, that's why it asks me which branch, because I don't want to make updates for my website for every time I change something. I need to validate it only if I choose, for example, this repository, this branch to be updated. I don't want to update the master. The master or the main, it's always the latest one. Let's call it the beta version. So I come here, and of course, please review the Git course. It talks about those things. So here I tell him, for example, any branch, or I tell him I want the master. So I will write here the master. So every time I do an update on the master, I need a new build. And here it asks me which file do you fire every time I build. I ask him, I want to fire the Docker file. Now, what is the Docker file? The Docker file, this is the file where we create our container. So we ask him from where we bring, because here is how Docker file works. So the Docker file, this is, for example, my application, but my application, since I want to create a whole container, I want some dependencies. And this application, I want it to run on an operating system, which means that this apps needs Ubuntu, of course. And Ubuntu, I need to install Python on it. And then I will run my application. So when I will have the last container, I will have this block. So to tell him how to bring me this Ubuntu and this Python, those are layers. What I ask him to do, I ask him from Python 3.9. So bring me this image, and then from this image, I want you to compile the code and then run this. So why did I include this no cache directory? Because when you create your container needs to be as small as possible. Don't make bigger containers. Smaller better, because it's a process, so they need to go to the RAM, they need to get transferred, which means that the smaller your container, the better they are. So that's why I do no cache directory, so to create a smaller container. And then I will show you something. So when you do a container, let me write something here, Docker file. For example, I have on Ubuntu, this is for people that come from Ubuntu. When I do something like this, run, and then I do apt update, and then I do run apt install, for example, let's say, for example, Python 3 Tornado, or that's a bad example. So let's say, for example, Git, something like this. I depend on Git. Never do that. Why? Because here, every time there is a command, it will create a layer. Because what is a container? A container, this is something like that. It creates an image. So this is what we call a base image. And every time it creates a layer. So the layer that we are writing on it is always the upper layer. This is where we write. So every time I execute on my Docker file an instruction, it creates a layer, and then it creates a superior layer, and so on. So here I will have two layers, which means that I'm losing my resources. That's why we don't do that. We always add something like this. Why we add the end, the logic end, to make those two operations run in one single layer. So don't try to split a lot of operation in lot of layer. Always try to regroup them. So let me go back. This is my file. So I was in Cloud Run. Okay. Now I want to execute every time this Docker file. Let me save. And now it creates a trigger in my cloud build. Every time I push the code, I push my source code to this repository, there is a build. And now I ask him to allocate only during processing. What does it mean? Because we said last session that in Cloud Run, we only pay for what you use. That means that if our application is idle, it doesn't receive any requests, it must stay idle. And in advanced setting, here is the variable and secrets. And this is where we said the config. So we are satisfying this third something like this third rule. So the third rule, we use it in variable and secrets, for example, where I say db user, and the db user, I say this is how he is called. So since we don't have any variable in our application, let's come back to container and then the container port. So the container port, this is port binding. So when we use microservices, we need the services to talk to each other using ports. I explain you what happens is that when I upload my microservices, architecture of microservices, we have a service here, a service here, a service here, service here, and then we have an entry point. So a user comes to the entry point, and then it goes somewhere, and then those service, they must talk to each other. And of course, me, when I go to this website, it must be 18 or 443 for HTTP and HTTPS. And of course, don't use HTTP. Everyone is going to HTTPS. And then here, I need those applications to talk on ports. So for example, in 8080, this one must be in 888, this one in 4000, for example, and this one in 5000. So I need to open some kind of ports on my services to make them talk to each other on this service. And of course, the user must never do that. Never let him do that. So let me come back. So the port by default on Cloud Run is 8080, but since my application is in a different port, if I use, for example, here 8000, here I need to change to 8000. So you see now why I should never change hard code those configuration values, because if I write them on my application, I can have problems. So that's why always try to make a configuration outside your source code. So I will leave it by default 8080, and then in 8080 I choose the memory and how much CPU. Those are just simple configuration. And let me come back here. I think my application, this application, I think in 8000. So I need to configure my Cloud Run here to 8000 because I'm going to upload the Windows version, not the Linux. The Linux, I just made it to show you something in a few minutes. So let's do next. And then it asks me about the file rules, and then I don't require right now any authentication because this is like a demo, but always run an authentication between services. And I just created my first application. So my source code, what happens now, it's building. So I will show you what happens. So here is what's going on in the back. Oh, sorry. I have my source code here. So let's call it del. It's my machine. And then I bring it to my repo, which is Cloud Repository or GitHub. And then what I did, I created Cloud Run. So this is the Cloud Run. And the Cloud Run, I asked some cloud build. I told him every time I upload a modification, let's call it diff for difference. So every time there is a difference in my source code, I want this repository to fire a cloud build. And in reality, it is not the repository. It needs to go and be uploaded in GCS, Google Cloud Storage. And then every time there is a build, I want to create a container and host it in GCR, in Google Container Registry, the Docker Hub equivalent, and then bring it and run it. So me as an end user, I will just consume Cloud Run. I don't care about all this. All this is done by the developer. Me, I just go to the website and then I will just check on this website. And this is what happened now. It's routing the traffic. The IAM is for identity and access management. This is what we call RBAC. RBAC, this is for role-based access control. So I don't give access for anyone. I just give it for some stuff. So it's building. It's routing the traffic. So let me unzoom and check. As you can see, it's running. So what do I have as a problem? Do I have any problem? Because it should not take that much time. So let me check the website before it finished. Yeah, it's still running. So let me go to the details. The trigger is cloud build, and permission. No, I don't need permission. So as you can see, I just generated from the Cloud Run, I generated the YAML file. Now, why do I need this YAML file? So this is the YAML file. Let me copy and paste it directly here. So let me run a new file. Sorry for this. So let me new file and then paste it. So here is a YAML file. So the YAML file, this is when we use Kubernetes, because as I said, if I come here, I told you that Cloud Run is built on Knative. And then I told you that Knative, this is something that make it easier for us to use Kubernetes. And in Knative, we said that there is the Knative serving that makes scaled up, down or scale up. And then we said that it's use what we have the cloud build to build the container, but now it doesn't use anymore the cloud build, it used the Tecton. So in case we want to use the Kubernetes and not the Cloud Run, we can directly use this generated YAML file. So as you can see, if I come here and type port, so the container port is this file. So why it changed this? So let me come back here. I think I made a mistake. Sorry for that. So let me come here. Okay, I made a mistake. That's why it doesn't work. So let me come back here and let me delete. So let me edit. Yeah, see? The cloud build. Yeah, the port. You see? I made a mistake in the port. So let me upload a new revision. And variable, see, I didn't ask for this. I don't know why it bring 799. I didn't ask it for 799. I asked it for 8,000. So it will rebuild, and this is what we called the immutable infrastructure. The immutable infrastructure, as you can see, I didn't modify the source code. What I do, I create a container from scratch. So every time there is a new build. So now if I come here, now it works. See, I don't know why it modified to 799. 799. So now I have my website working, and as you can see, I have 3 builds, and this build, it crashed, which means that I don't need it anymore. I will delete it. This is a container, but the port that we configured and the one that we hard-coded, they don't share the same value. That's why it crashed. And this one, it works. So if I come to the website, as you can see, it is an HTTPS. So you get a free certificate. Don't worry about the certificate. But if you already bought your own domain name, you come to this and then you click on manage custom domain. Custom domain, this is where you are going to put your own domain name, or you register domain and then it brings you to the Google domain registrar. So let me come here. So we corrected this, and as you can see, I got some bug because my port and the one in configuration, they are not the same. This is why we always prefer the configuration. Don't hard code your port. And then I checked the log. The log, this is where I can see what happened with my system, because always keep the log and log management separate from the application. On GCP, this is what we call, let me come here. So now it's named operation. And as you can see, we have monitoring, debugger, login, and always check for the login. And in the past, that was called stack driver. So if you didn't call it long ago, the stack driver now is renamed to Google Operations. So this is where I can see. So if I go to login, as you can see, my application and the login are separated. This is not login. Login, this is the information that we, so if I come here, let me show you what is a login. So if I come here and then let me quit. So if I do cat var log syslog, this is the log. This is what happens in my operating system. So I check and I see if someone come to my machine and all that stuff. So this is what we call the logs. And then you can check the logs and study them and export them to BigQuery. You can do whatever you want. So this is what we call the login. So I keep the login. Now, let me come back here. The concurrency and the process and all this, they depend on this build, release, and run. And this is what we do on containers. But let me say something. Containers doesn't mean Docker. Containers, there are many technologies now. Because if I come to GitHub, the Docker itself, there is no only Docker, because Docker is the brand. That's why we have what we call Docker Enterprise Edition. So what we use now is what we call the Docker Community Edition, CE, not the EE, not Docker EE. This is for Enterprise Edition, but we use CE for Community Edition. So if you see Docker, you will see the word Moby. If I come to the Docker engine, you will see that it was forked from this project, Moby. So the Moby is the bigger project. This is the open source project. So to make you understand the difference, here is a small picture. In the small picture, if you already used Red Hat, this is the difference. So let me come here. So as you can see, in Red Hat, we don't use the Red Hat for free. There is a project that is called Fedora, which is open source, and then they take everything that is good in Fedora, and then they realize what is Red Hat, which is commercial, and then from Red Hat, there is a version that is free, which is CentOS. Now, of course, there is no more CentOS. It's a big story. So the same is for Docker. So what we use now for Docker Community Enterprise, we fork it from a big project that is called Moby. And from the Moby, we take the Docker and then the Docker Enterprise. But look at the difference. Here, we realize first our community and then we bring the enterprise. But in Red Hat, that's the inverse. We create the enterprise and then we create something for the community. So that's a big story too. So just I want you to understand that Moby, this is the open source project for Docker. And then because there is no only Docker in the world, I need you to understand that there is also what we call Podman. So Podman, the difference between Docker and Podman is that, can you please add me 10 or 50 minutes? I need 10 or 50 minutes so I can finish. So the Podman, here is the architecture between the difference between Docker and Podman. So Docker, what we use is what we call Docker CLI. Docker CLI, this is the, yeah, thank you. The Docker CLI, this is the where we type the command Docker. And then there is the Docker process. It talks with him. So here we have two things. We have a problem is that we have what we call a single point of failure, which means that a lot of Dockers talk with only one single point. So if this crash, all the other crash. And then we have that we need the root. We need the group where we give him the root access. So what they did, people say, why we don't create a container that runs only by himself, and then we don't need a root, what we call rootless. So rootless, that means that we don't need root, but we have some drawbacks, and then we don't need another tool to run Docker, but we will directly run it on systemd. Systemd is what makes the process run, the daemon run in Ubuntu, in Linux. So this project is called Podman, and there is not only Podman, it's a stack. So here is a small drawing. Of course, all the links are shared. So the Podman, it calls the runc, the runtime. And then here, as you can see, there is another process that Docker talks with him before going to runc. And if I show you another picture to better understand, yeah, this one. So to build a Docker, we only use the Docker tool, but for Podman, they use another tool to called Builda. So Podman, this is the one where we run the command Podman, and then the Builda, this is to build the container from the Docker file, and Scopio, this is where we upload our image. So in case you want to use the Docker Podman, as you can see, Podman, so let me run this. So if I do Podman run, or let me do Podman help. So if I unzoom, as you can see, this is the same commands as Docker. So there is even people who do something like this, alias Docker equal Podman. This is something like they replace Docker by Podman. And this is a project that works on Red Hat. So you can go and check. So this is so you can understand that there is not only Docker in the world. So, and those are some alternatives. So Knative, Tekton, and let me come back here. Let me continue. So we build and release and run, and it works. We used one single, we used one single repository and our code runs. Now, dev prod parity. We need to keep our environment the same, which means that if I develop on my machine or if I go to the cloud or GCP, I must maintain the same tools, the same practice. So that's why in Cloud Run, if you have I show you the first trick. If you have GitHub, you just create a README file. So in the README file, this one, if I come to the README file, you just add this. So you just add this line. So this line, if you add it, what happens in your GitHub repository, you will have this nice button. This. So if I click on it, check this out. I will click. So I didn't program anything. I just keep my GitHub. I will tell him, okay, I trust this. Then I confirm. It will bring everything, and it will run a new Cloud Run instance with my source code that is on GitHub, and then I check my code, and it will work. As you can see, everything will be automatized. No overhead, nothing. Everything will work now. So you just need to add this line. So if I come here and I do cat readme, this is the only thing you need to add to your GitHub project. And then if it's Node.js or if it's Python or anything, since it's just a container, it will come to Cloud Run and it will run it on your session. And then you can check the project. I will not go until the end. So I just, So this is it. You just add this button on your repository, and then you don't need to configure anything. So if I come here, I come back to my Google Keep. So the dev and prod parity, I keep my same practice, and this is what we call the DevOps. The DevOps, this is all the practice that makes me scale and make my application uh, my team. I will make my team collaborate in the perfect way. So I don't need to have separate teams. One team, they will use the production or development. They use the same thing. Now, since I'm using containers, I'm using process, which means that if I want to scale up or scale down, that will be easier. So because as a microservice, if you see this, microservice, they are just processes, which means that if I want to run many processes in the same instance, I will just scale them up. If I want to scale them down, that's fine. They are just processes. So container, using container, I'm using this rule, process. And if I come back, I forgot the dependencies here. I talked about the Python dependencies, and then I have also the Docker dependencies. So the Docker file and the requirement.txt or the for the npm, this is for dependencies. So the process and then the concurrency. Since this is the process, I can scale them down, scale them up, and so on. And since they are containers, difference between container and the virtual machine, we said that in container I can start them, I can kill them, no problem. But in a virtual machine it takes time and I can have problems. So that's why sorry, that's why better to use container. Okay, so let me just yeah, sorry. So the latest thing is for admin process. This is something that you can have directly on GCP. So if I come to GCP and come here, you can have Cloud Scheduler, and you can have Cloud Scheduler where you can use what we call schedule, and you can do whatever you want. Cloud Tasks, where you can program your tasks. Let me check if I have the connection. Yeah, I have a question. Sorry. Okay, so now since in the beginning I show you how to use Cloud Run using a Docker file. Now imagine some people say, I hate Docker file. I don't want to understand what you wrote here and so on. So that's why Google now support what we call the cloud packs, the build pack, sorry. So the build pack, this is a new way to understand your source code without writing a Docker file. This will be created automatically. The container will be created automatically. So let me delete this application, and I will show you how I will redeploy it with one single. So let me delete this. Okay. So as you can see, if I come to cloud storage, I will find it here. If I come to cloud registry, I will find the source code too. So here, since I deleted, let me now, there is no service as you can see. Now let me come to my source code and let me run gcloud run. Now gcloud run, we said that this is for Cloud Run. So here I don't need to upload it first and then call cloud build and so on. I just need to do source here and then the port is 8,000. So I just run cloud run, and of course I need to deploy. So as you can see now, I didn't put anything. So it detected that it's a Python application. Yes, I want this service to be called like this. And then, do you want to continue? Yes. As you can see, it asked me, he said that he is going to upload my source code to the artifact registry. Do you want unauthenticated? As you can see, the default is capitalized N. I say yes, I want unauthenticated because I want to access to my application by a simple click. So as you can see, I just uploaded an application without even writing the Docker file. So this is what we call the build packs, and there is for Node, there is for Python. You can have them and explore them. So if I come back here, it will create my container. As you can see, it was uploaded. It is building it. It is as you can see now, the logs are being registered, and then I will have a new application. So if I come here, the admin process I explained it with the cloud task and all that. So we got a perfect score, 12. So when we use the containers on Cloud Run, everything works as the 12 factor apps. As you can see, and now it's already here. Let me pass the link. And there we go. And we got this. Do you have any question? Before I read the question, let me show you something we already did with App Engine. So if I refresh here, I will find that I'm using one revision. So imagine that I want to check the source code. So as you can see here, I hope you learn. So let me modify this sentence. So let me come to nano handlers. And then here, let me write something like, yay, it works. And then let me re-upload this. So if I re-upload this application, it will delete the old version and deploy a new version. But I don't want to deploy it yet. So what I do, instead of telling him to wait, I will write something like this, and then I say ag green. I will use what we call the blue-green deployment. And then I will say no traffic, which means that upload this, but I don't want you to reorganize the traffic. So I will always hold the old image until I decide to redirect people to the new version. This is like a beta. So it will upload it. And since I'm using the same service, there is no difference. So waiting to be deployed. Let me check if there are any questions. So do you have any questions? Of course, the link are shared. So do you have any questions? No questions. So if you have any questions, just ask them. So before we finish, as you can see, look at this version. This link is weird. As you can see, this link is weird. You have this green and then 3 dashes. Why? It asks me, it tells me that my website is still running, but in case you want to check your new version, you can come here and then check the new version, but I'm still using the old version. So in case I want to go back to this version, what I tell him now I want to redirect the traffic. How I will do it. So instead of, I can do it with the console, but let me do it directly here. So if I click here, because last time we did it on App Engine directly on the web page. So as you can see, this is 100% to this version and 0% here. So if I come to manage traffic, it asks me, do you want to change? I say yes. I want 50% to the new version, 50% to the old version. Now if I save, 50% of the traffic, they go to the new version, 50% to the old version, and then I will make the transition easy. So if I come back now to this website, the original one, and I refresh, so 50% they go to the old, 50% they go to the new. This is Cloud Run. Now I bring you something about Kubernetes. So in case you want to learn Kubernetes in your own machine, there are many tools because Kubernetes, it's difficult. No people say, hey, that's difficult. Their architecture is weird and so on. So what you do, you just, of course, the links are there. So there are people who tried to make Kubernetes run on your laptop on a simple machine. How? Using some tools. So the tools, there is one tool, but I will not show you only one tool. I will show you a lot of tools so you can have the choice. So if I come to the cloud, the CNCF website, the Cloud Native Computing Foundation, this is the W3C for cloud. As you can see, there are many tools, and there are tools that you install, and then you have online tools. So the online one, we have the GKE for Google Kubernetes Engine. This is it. So if I come here, this is the Kubernetes. Now if I come here, this is the Kubernetes engine where you can manage your Kubernetes easily. But in case you want to practice first, you can have this cheat sheet or spreadsheet. All the tools are here. You can browse them. So here is the link where you can install it in the hard way, where you are going to learn. You want to get a lot of money. Learn how to install Kubernetes and how to use it and how to secure it. Now the tools. You want to practice it on your machine? That's fine. Install Minikube. So Minikube, this is the way how we are going to deploy our small single machine Kubernetes, where you can learn and all the commands like kube control and all the commands you need. And then here is the cheat sheet. There are many cheat sheets. I just show you one, but you can find a lot of cheat sheets how you are going to use the Minikube. And this is the same thing that you are going to use, the same thing that you are going to use in production in GKE. Now, you don't want Minikube, that's fine. If you have Ubuntu, you can install the canonical version, which is called Micro 8s. Micro 8s, this is the implementation of Minikube on canonical products like Ubuntu. So if you have Ubuntu, go with Micro 8s. You want something lightweight, for example, for your Raspberry, that's fine. You have what we call K3s. K3s, this is a way how you run your Kubernetes on a simple ARM, which is Raspberry Pi, where you can run Kubernetes on your Raspberry. That's fine. You want something much more easier, you use the K3D. The K3D, this is the upper layer on top of K3s to make it even more easier. You want another project, that's fine. You have Kind. Kind, this is, as you can see, every time I show you something, it's validated from Kubernetes. So this is the same thing you use in Kubernetes. So Kind is a tool for running local Kubernetes and so on. So you can use Kind, or you can use AgroKube. So that's it. And as you can see, all of them are Kubernetes certified. Everything is on internet. It is just up to you to learn. And we are here to help you to learn. So if you have any question, please ask them. Thank you very much, Omar Ibrahim. You are here since the beginning. So since there is no question, Thank you very much and see you in next session.